All right, guys, we're going to go through here and get these notes. I'm going to go through pretty quick, so stay with me. And again, if you need to rewind, then rewind. Make sure you get all these notes. The last one on the notes we're going to save to do on Monday morning or Monday when you get back. So here we go. So this is exponents. We're starting exponents. Again, exponents, that's the number, the little number above. There's your exponent up there. There's an exponent. We're going to multiply exponents. All right. So the first part is here is, I'm just going to abbreviate, the exponent. Exponent is a small superscriptive number that shows how many times a symbol or number is to be multiplied. It's just what we just talked about. It's the small little number up there. You've all seen it. You know what I'm talking about. Okay, when we do it with exponents, the base number, so the base, that's the big number. So in this case, the base is 2. In this one right here, what's the base? The base is x. The exponent, that's what we just talked about. The exponent in this one is 4. And in this one, the exponent is 5. Okay? Now, operations with exponents. Okay, this first one, the law of zero exponents, that's when you have an exponent that is 0. Anytime you have an exponent that is 0, it doesn't matter what the base is, the answer is going to be 1. So it doesn't matter, here's an example, it doesn't matter if I said 152 raised to the 0 power, that equals 1. Okay, exponents to the first power, again, same thing. Any number raised to the first power is going to equal that base number. So in this case, the base was x, so it's just x. So over here, 152 raised to the first power, that's going to equal 152. It's just that same number that is the base. Okay, this part right here, x to the 8th power, what I want to show you here is the property that if I said x to the 4th, that's going to equal x times x times x times x. How many x's are there? 1, 2, 3, 4. That's what these exponents are representing. So let's say I said 4 raised to the 3rd power. That's going to equal 4 times 4 times 4. That's terrible. It's not subtraction. That is a dot. That is multiplication. 4 times 4 times 4. Why are there just 3 4s? Because the exponent is 3. So if I put 4 to the 5th power, it would be 4 times 4 times 4 times 4 times 4. All right. To multiply two powers that have the same base, all you have to do is add the exponents. So what that's saying is, okay, let's say we have x to the 4th times x to the 3rd. If I multiply those two together, that's going to equal or be the same as x to the 7th. Again, when you multiply, the key right here is multiplication. That's not addition, that is multiplication. Have the same base, so they're both x. So you can multiply these together. You have 4 plus, because we're going to add 4 plus 3, so now we have x to the 7th. This same problem could also look like this, x to the 4th in parentheses times x to the 3rd in parentheses. That's going to equal x to the 7th, because all we had to do was add the exponents. Okay, to simplify an expression involving monomials, write an equivalent expression in which each base appears only once. So like if you have x as the base, the x only appears once. And fractions are in the simplest form. So simplify your fractions. Next page, backside. Here's some examples. I love this page of notes because it's just pure examples for you to see these properties worked out. Here we go. We have 3n squared times 4n squared. Okay, so the first thing to do, multiply these numbers out in front. So 3 times 4, that's 12. Okay, we have n and n. So they are the same base. They're multiplying. So again, if you go back to the last page, it says when we multiply, right here, when we multiply, we add the exponents. So go back. Add the exponents. We have n, and then 2 plus 4 is 6. There's your answer. Let's do this one. Again, you got the number out in front. Multiply them. Negative 3 times 5 is negative 15. And you have, okay, let's look at your A. You have A squared and you have A. All right, so we're going to have an A. We know we have an A. We got 2. That's a 1 right there. There's not a number there. It's like a 1. So you have 2 plus 1. That would be A cubed. Same thing with the B. You have 3 and 4. 3 plus 4 is 7. Negative 15, A to the third power, B to the seventh power. Okay, look at number 3 here. This says x squared plus x2. Again, this is where I said make sure this is not multiplication. This is addition. So let's think back. What if I said x plus x? How many x's would I have? Well, I would have 2 x's. Same thing here. All I have is 2 x squareds. There's your answer. Oh, look at the, okay, here we go. This is multiplication. You got your dot in the middle. So now, when we multiply, we add the exponents. 2 plus 2, this will be x to the 4th. Got it. Number 5, okay, this is addition. This is addition. Number 5, they have the same base, but do they have the same exponents? No, they don't have the same exponents. This problem you can't simplify, so the answer here is just 2x to the 4th plus x to the 3rd. Again, to combine these, but look, like on number 3, we had x squared and x squared. We added them together, so we had 2x squareds. This is x to the 4th, and this is x to x cubed, x to the 3rd power. You can't combine those. They're not like terms. 6. Multiplication. Okay, here, so now we got to switch gears. We're multiplication. We got 2 out in front, and then you have an x. Since this is multiplication, we add the exponents. We have 4 plus 3, that is 7. It'll be 2x to the 7th power. Number 7, all right. Oh my gosh. We have parentheses. When we have parentheses, what do we got to do? Well, we got to distribute that times that times that. So let's do the first one. 2ab times ab. So you're going to have a 2. A, so that's a squared, because this is this is multiplication. And then you have b times b, that's b squared. Okay, now we do the other one. 2ab times 3a squared plus b to the 5th. So this is going to be negative. 2 times 3 is 6. A times a squared, that's going to be a to the 3rd power. B times b to the 5th, well, what's 1 plus 5? 6. Okay, got your answer. Over here, how can you solve these? You got fractions on both sides. All right, you got fractions. Well, the first thing I did, I'm going to multiply the tops, and then I'm going to multiply the bottoms and see if I can simplify from there. So let's multiply the tops. 20 times 12, that is 240. X squared times x to the 3rd, this is multiplication, so you add the exponents. 2 plus 3, that's going to be x to the 5th. You got y times the y to the 5th. You're going to add the exponents, so you have y to the 6th, because again, that's like a 1 right there. Okay, so there's the top. The bottom, 3 times 5, that's 15. If I use my calculator, I can see that 240 divided by 15, I can simplify that. When I simplify that, this is going to equal 16, and then these all stay the same. X to the 5th, y to the 6th. There's your answer. Again, how we solve these with fractions? Multiplied the tops, multiplied the bottoms. So that's where I got the top, I got the bottom, and then I simplified. 240 divided by 15 is 16. Got our answer. Okay, number 9. Now we got a bunch of different stuff going on here. This is the last one we're going to do on this video. We'll do number 10 to Monday. Go through and look at your like terms. Okay, we have an x to the cube. We have x cubed. We have x cubed. So let's combine those. You have 5 here. You have plus, and again, that's like a 1 in front of there. So how many x cubes we have? Well, we have 6x cubed. All right, let's look at the y's. How many y's do we have? Well, there's a y there. That's y to the 5th. Again, not the same. Y and y to the 5th, not the same. So I'm just going to leave. This is the only y we have. So we have minus 7y. And then we have, okay, our xy's. We have 8xy. Oh, right here, 3xy. So you have 8, it's a positive 8. 8, this is a negative 3, so 8 minus 3, that's going to give me a positive 5, and then it's xy. xy. And then the last thing that we got right here is y to the 5th. So we have plus 4y to the 5th. All right, guys, we'll continue working with exponents all week, and we'll